Alright, in this video, I will be teaching you how to draw the rays of light, how it is being reflected in a convex mirror. As we all know, convex mirror is a diverging mirror, meaning it scatters the light or it spreads out the light, okay, once it is being reflected in our convex mirror. So I will have the four basic rules here. But to make our diagramming a bit easier in locating the image of our convex mirror, we can have two of this four basic rules. The first rule, we have the PF ray. P stands for the principal axis, and the focus or focal point ray. Incident ray, that's the ray from the object and then it touches to the surface of our convex mirror. Incident ray from the object parallel to the principal axis and then reflected as if aligned with the focal point. Okay, later I will be showing you how to do it. We have the FP ray, the focal point or focus and principal axis ray. We have the incident ray directed towards the focal point and then reflected parallel to the principal axis. And then we have the CC ray, incident ray directed towards the C or the center of curvature and reflected back along its own path. Then we have the V ray, incident ray directed towards the pole or vertex at an equal angle, or that's the law of reflection can be applied there. The CC ray is the least rule used in locating the image, but we can be able to use it in doing our diagram if we like. Okay, so I have it here a question or a situation. You have to use the rules V ray, this one, and the FP ray in locating the image of a convex mirror. First and foremost, we will be, you know, illustrating our convex mirror. So it looks like this. Okay. And of course, we need to draw our principal axis. That one. Okay. Again, this is our principal axis. Okay. In doing our convex mirror diagramming, we will be placing our focal point or F and center of curvature at the virtual side of our mirror, behind the mirror. Remember, this is the real side of the mirror, and we will be placing our focus here. Length from the P pole or vertex, and then that's our F. Then the same length between P and F, let's say 2 meters. 2 meters from F, that will be our center of curvature. And then this 2 is the radius of our convex mirror if we want to extend our circle here. So this is going to be the radius, right? Okay, so it's equal in length. All right, sorry, I deleted the center of curvature here. Let's continue. So what if we will be placing our image here away from our convex mirror? That's our object. It's the object. Now, the first thing to do, we will apply the V-ray. I will be using a green arrow to represent the incident ray. And then I will be using the blue one to represent the reflected ray. Okay, so let's begin. Using the V-ray. Incident ray directed towards the pole or vertex at an equal angle, showing the law of reflection. So from the tip of our object, we will draw at the incident ray from the tip all the way to the P or pole or vertex. Then we have an angle here. And then following the law of reflection, it will have the same angle of reflection. Angle of incident is equivalent to the angle of reflection. So I'm going to be very careful in doing it. Okay, I guess it's all right. Now, this is the reflected angle. They must be the same according to the law of reflection. All right, next we need to do the this one, the FP ray, in locating our image here. The incident ray directed towards the focal point F and then reflected parallel. When we say parallel, the lines are not intersecting. So if this will be our principal axis and it's going to be our reflected ray, for example, they're parallel. Okay, first things first, incident ray directed towards the focus. So how are we going to do it? Look at how I will do it. This is the focus. I will make an imaginary line here. Okay, so that is where I will uh, point my arrow. Oh, hold on. I'm gonna be pointing my arrow there. Okay, that's it. So I just use it as a guide, but it does not exist yet. And then what's next? The reflection will be parallel to our principal axis. This is gonna be our principal axis here. Remember this line. So our reflected angle will be parallel to it. Look at how I will do it. Just like that. They are parallel. These two lines here are not meeting each other, so they are parallel. Okay, next. Since no intersection, our reflected ray goes this way and then our second reflected ray goes this way. No intersecting of rays or light rays here, so no images form. So how are we going to locate the image? We will be extending our reflected rays, the blue arrows here. We will be extending these arrows through our virtual side. Okay, so let's use the broken line to do it. So just focus on the blue arrows here, just like this, the perpendicular reflected ray. So we will have to extend it here through the virtual side of the mirror. That's it. And then the other one, okay, there you go. So there is now intersection at this point, and this is where are we going to draw our image. This is the object, and this is going to be our image form. So the characteristics of the image form in a convex mirror. The image form in convex mirror, as you will compare the size, it's smaller than the object. And then the orientation. Orientation means how the arrow is being drawn. So it's upward, uh, erect, or upright. Actually, same with the object, right? If you look at the object here and the image form here, they are upright, erect, or upward. So same in orientation. Next, where did the image form? Is it under real side of the mirror or the virtual side of the mirror? Very obvious that it's a virtual image. Okay, the type of image being formed, it's virtual in nature. So I hope you learned something from this video, I will have another sample here. Okay, I will erase everything, but this time we will not be using these two rules. Let's say we will have the PF, at the same time the FP rules in determining the image of a convex mirror, or formed uh, through convex mirror. So again, let's draw our convex mirror here, and of course our principal axis, then in drawing the, you know, convex mirror, we will place our C and focus or focal point here, and this is going to be the center. That's P, or in other references it's called the vertex. Now what if we will place our object near the convex mirror? So using the PF and FP, we will try to make the diagram, or the ray diagrams, or ray diagram of our convex mirror this time. We will still be using the green arrow to represent the incident ray, and then the blue one for the reflected ray. So PF here, the incident ray from object parallel to the principal axis. Remember, parallel, not intersecting line. Okay, and then reflected as if aligned with the focal point. So how to do it? Watch carefully. Now we have our incident ray from the tip of our object touching the convex mirror, and then it will be parallel to our principal axis. As you can see, it's parallel. Okay, next, the reflection, or the reflected ray as if aligned with the focal point, as if aligned. So now the reflected ray as if aligned with the focus. So you will try to draw it here. I hope I can make it. Okay, I will change it somewhere this side. This will be our focus, and this is gonna be our C. Okay, sorry, I change it to satisfy our illustration here. So as if aligned with the focus. I hope it will be better this way. Okay, that's good. So that is how are we going to do the reflection, as if aligned with the focus. So you just have to trace it here, and then you will put the ray on the real side of our mirror. This is the virtual side behind the mirror. Now in FP, same as what we did a while ago, the incident ray directly towards the F, and then reflected parallel to the principal axis. Okay, then how to do it? Again, this is our focal point, or F. So we have to make a guide here, just like that. Then that is where are we going to draw our incident ray directed towards the F. So we will just try to do it this way. It's now towards the F. Okay, and then we will try to erase these guides here. Okay, the reflection must be parallel. Again, the line of parallel, meaning to say they are not intersecting, they will never meet, just like that. So the reflection of it, or the reflected ray, will be parallel to the principal axis. This is going to be our principal axis. Okay, this is also our principal axis here. So it's parallel, so I will have to do line not meeting the principal axis. Just like that. Okay, no image will form because first reflected ray going to this direction, the other one's going to this direction. No intersection, so we will try to find out the image by extending our reflected rays again and again. Focus on the blue line, the blue rays. We will extend it here by using broken lines. This is our first ray. Try to look at it. I will extend it, passing the focus. And then our next reflected or blue or purple line, or purple, not line, but purple ray, extend it through the virtual side of the mirror. And there you go. We have our intersection here, and that is where you will be, illustrating the image form. Still the same, image is smaller than the object, smaller than this object, and then it's upright. The orientation is upright or erect or upward. Same with the object. And then since it formed behind the mirror, so the image is said to be virtual. Bottom line, the image formed by a convex mirror is always be smaller than the object, upright orientation, erect or upward, and virtual. Cannot be projected on screen. Thank you for watching, and I hope you enjoy watching this video. Don't forget to subscribe this channel so that I will have the motivation to do videos like this in the future. Thank you so much, and see you until next time. Bye for now.